Hey everyone, so this is Frank. We're going to be using Frank here in a minute, but first I want to talk about how blood moves through the body. So let's say that blood starts in the veins. That blood is on its way back to the heart, here at the right atrium. That blood is then going to go down to the right ventricle, and I'm not going to include the right atrium in our flow chart because I want to focus on chambers of the heart that pump blood outside of the heart. So from the right ventricle, that blood is going to move up into the lungs. And then from the lungs, the blood's going to be pumped back down to the left atrium and to the left ventricle. So recall, we're not going to include the atrium here. And then from the left ventricle, that blood's going to get pumped out into the body via arteries. Okay. So we should say that blood that's moving into the lungs from the right ventricle is full of CO2, carbon dioxide. Okay, this is waste, and we're trying to get rid of that waste. The blood that's coming from the lungs is full of oxygen, and this is energy. We're going to use this to go about our daily business. Now let's say we experience heart failure, and that problem is centered right here, the left ventricle. The ventricle is a pump. It's pumping blood out of the arteries, and it's receiving blood from the lungs via the left atrium. So what this basically means is that we have backup due to our pump. It's very similar to what you would experience if you were stuck in traffic on a busy rush hour morning and there was a car that was broken down up the road from you. The left ventricle heart failure is the car accident, right? So upstream of that problem, you have all kinds of congestion, right? You have traffic for miles. And we're going to talk about that. That's exactly what's going to happen upstream of the left ventricle problem. We're going to have congestion in all of these systems. Okay, we should go ahead and label our systems as well, because we're going to talk about this, 1. We're going to talk about the lungs, 2. Okay, and then downstream from the problem, things look a little different. Instead of there being so much congestion that no one can get through, downstream, the problem looks a little different. We're not getting enough blood that moves down into the arteries, right? So this is going to be our third problem. And we can go ahead and talk about this one really fast. So downstream, if there's not enough blood getting through the left ventricle and out into the arteries, then the body's not going to get enough O2. If it's not getting enough oxygen, then we're going to feel fatigue. And that makes total sense. You need energy in order to do the things that you need to do. And if you don't have that, you're going to feel fatigue. So this is our major symptom that results from downstream lack of blood flow due to heart failure. So let's talk about some of the things that go on upstream. Okay, so let's take a look at the lung here. So in the lung, there are a couple of really important structures, one of which we call the alveoli. The alveoli. Okay? The alveoli is this little air sac that's surrounded by capillaries. Okay, so this is a capillary that's carrying blood. Let's say that in the first part of this capillary, we're dropping off CO2, and in the second part of this capillary, we're picking up oxygen. Now, it doesn't exactly work like this, but I'm just trying to illustrate to you that in the capillary and the alveoli complex, we're both dropping off waste and picking up oxygen. So let's say we have this congestion that we've been talking about. So what happens? So say the congestion starts here. Here's the traffic jam. We move back upstream into the lungs. What that means is that blood, fluid, is going to back up into the lungs. So if we're going to draw our alveoli, now under the influence of heart failure, what we're going to notice is that these capillaries are much fuller with blood than they normally are. But I haven't drawn them as fat as I should. What I really want to show you is that the important thing is that the space between the capillary and the alveoli has changed. It's gotten much bigger than it was over here. That's because some of the fluid that backed up into the capillaries diffused into the space between the alveoli and the capillary, and when you increase that space, it's a longer distance for oxygen and for CO2 to travel through. So what ends up happening is this gas exchange is not near as efficient when we're suffering from heart failure. So if you're suffering from heart failure and you're not getting enough oxygen and you're not getting rid of your CO2, you're going to experience shortness of breath. It's going to be very hard for you to breathe when you exert yourself. And in some cases, it can even be bad enough that you have shortness of breath when you're not exerting yourself. Okay, so let's talk about another shortness of breath related symptom. So it's called paroxysmal nocturnal, which is misleading, and I'll tell you why here in 1 second, dyspnea. So dyspnea is generally referred to as difficulty of breathing. Paroxysmal means that the symptom comes on quickly. And of course, nocturnal means night. What this actually means is that the person suffering from heart failure is going to have difficulty breathing when they're asleep. And the reason that happens is when you're asleep, your central nervous system tells your heart, hey, relax. You don't have to work near as hard as you were when we were awake. All we're doing is sleeping. Well, if your heart is not working well, you want it working at full steam all of the time. So this is a problem that arises in heart failure patients. And it doesn't matter if you're sleeping at night or during the day. The point is, you're asleep and your central nervous system is telling your body that it doesn't have to pump as much blood. Another shortness of breath related symptom is called orthopnea. So orthopnea has to do with gravity. So let's say we have a vein down here in the legs, and that vein is returning blood back up to the right atrium. Well, blood traveling from down in the foot all the way up into the heart is going to have to travel against gravity for this entire vertical distance, right? But when we lie down, that's not true. There's no longer a vertical distance between the heart and between the foot. So that blood is able to get back up to the heart way easier. That's all well and good unless the heart is not working well. We don't want to overwhelm the heart with blood. And that's exactly what happens when we lie down. That blood makes its way back up to the heart and overburdens this heart, which doesn't work well. So orthopnea is difficulty breathing when you lie down. We should say that both paroxysmal nocturnal dyspnea and orthopnea work by increasing this space. They encourage congestion here and then back up into the lungs, which ruins our ability to diffuse waste and get oxygen in. Okay? The last thing I want to talk about is hemorrhage. Okay, if this pressure is great enough, you can get breaks in the capillaries where fluid will start moving out. And that's dangerous. You don't want the capillaries in your lungs to be bleeding. You don't want them to be damaged. So those are some of the symptoms that happen in the lungs because of this upstream congestion. Let's talk about some of the upstream congestion problems that occur in the veins. So let's move down here to our leg vein. So let's blow up a picture of our leg vein. And let's say we have a leg vein that has fluid in it. Okay, and under normal circumstances, it has this much fluid in it. But let's say now we have heart failure, so we have blood backing up all the way into this leg vein. We have congestion behind the traffic accident, right? If there's enough fluid back up into this vein, some of that fluid will start pushing across into the neighboring tissue. What can happen is that causes swelling. And that swelling we call edema. Okay, so I'm just going to put a little number 1 because this is related to veins. So edema presents as extreme swelling in the legs, or it can be not so extreme. One thing you can do to look for edema is you can press on the tissue that you think has fluid in it, and if your fingerprint stays there for longer than is normal, it might indicate that there's water in that tissue. It sort of looks like a memory foam mattress pad, you know, where your finger imprint stays for a while. That's something that people often look for if they're looking for edema. So we've talked about what happens in veins below the heart. What about above the heart? So Frank's got this jugular, right, which carries blood down from the brain. Well, when the heart is experiencing heart failure, blood's going to back up into this jugular vein as well. And when it does, this jugular vein is going to pop out of the neck. It's going to look really obvious that this vein is sticking out. And when it does that, we say it's distended. Okay? So again, this is a problem related to the veins, right? Just like edema is. All right, well, what about the organs? Right? The organs also have veins that return blood from the organs to the heart. Well, the same thing's going to happen here. Congestion is going to force fluid and blood back down into these veins, in the liver in this case, in the spleen in this case. It's going to flood, so to speak, these organs with blood and fluid. So they're going to appear larger than they normally would if the heart was working correctly.